So I think we'll go to our next speaker, Florian Pestoni. Florian, would you like to take the floor?
Yes, thanks, Alex. So I'm actually pretty happy that we're doing this remotely, because I think when I put up my slides, I'm glad that I'm not in the same room with some of the other people. Let's see if this works. Yeah, so I'm going to start from a dark place, but hopefully there's light at the end. I think some of our speakers today have talked about some of the challenges that we're facing. And I think I wanted to be even more brutal, I guess, which is our food supply is at risk. And it's not just COVID-19, it's climate change, it's labor, it's growth of population. I don't think I need to spend too much time on this with this crowd, but I think that's critical. And I think agriculture has obviously changed from pure manual to machine assisted, but a lot of crops are still very manual, as we saw with earlier presentations. I think what I'm excited about is, again, a lot of changes that we've been seeing with, whether it's FarmWise here or Ironox. So there's a number of companies, and in fact, I tried to put a list together and I ran out of space. So there's really a great, and we've heard from many of them today, but there's a great number of companies around the world that are looking at this. I think Andrew earlier today mentioned that they were soil up rather than technology down. And I thought that was like a really insightful comment, that you can approach it from the point of view of, I have technology, what's a good problem to go solve? Or I have a problem, how can technology help? And I think both are valid. I think what's important is that they connect. Now, I would say that all of these technologies have something in common, which is they will all fail. Now, let me tell you what I mean by that, right? So I think every robot fails, it's not a fatal flaw. It's, it's hard. And in the field, in the fields, in plural, I think that's even harder, right? So many things can go wrong. So I think the key point I'm trying to make is there's, you need to fail to succeed. You need to fail in order to succeed, right? So, and learn from it and build a virtuous cycle around it. So we started a group called the Robot Operations Group. You can get more detail at robops.org. I'll share a link as well afterwards. So we came up with this manifesto about robot operations. And it starts with this idea that you need to accept that these autonomy exceptions or situations where the robot cannot do its job on its own will happen, right? And then you build them into your system as opposed to hoping that they won't. So I would encourage you to both learn about some of the discussion we've had, but also join the conversation. And there's plenty of ways to get involved. We have a meetup group, we have a discourse server, and the manifesto itself is actually open source. So if you really feel you want to make a change to it, and you can, find your way around a merge request in Git, then I would love to have you participate as well. So I think there's this idea of, perfection is the enemy of good, but I think for a lot of startups, it's the enemy of launch, right? So I think when you try to think about how long does it take to get to perfection, I think you can get pretty far along, and then you kind of, I think what we've seen in talking to hundreds of companies is there's a wall where if you try to aim for like, I think Alex, you were talking about level 5 autonomy for self-driving cars. But level 3, 3.5 is like super practical. Like my car has like adaptive cruise control. So I think that's kind of like the key concept. And what one of the things we try to do at InOrbit is what we call bridging the autonomy gap, right? Which is when you get to like 80, maybe you get to 95%, but that 5% is, can break your business. So what we do is we try to combine humans, robots, and cloud and AI in the cloud to really, together we think we can get to pretty close to 100%. I'm not going to go into too much about our platform, but know that there's like a dashboard that you can use to monitor hundreds or maybe thousands of robots and get real-time data. And if I have 2 more minutes, am I doing okay with time, Alex? All right, so I wanted to go into a little bit more detail. So first of all, highlight one of the pioneers and the people who are doing great work, Sarah Santosky and John and Brandon, who are the founders, are doing amazing work with IronOx. What I wanted to do is, and they're a customer of ours, so I wanted to take some of the things we learned working with IronOx and with other customers to talk about how you go from a robotics needs to something where we think we'll be able to help companies who are going through similar problems, right? So and it starts with very simple things like, being able to get the robot to do X. So we support a way to send remote actions. You don't have to build all the infrastructure to do that, or schedule recurring tasks. We find that a lot of times you have, for example, at an indoor farm, you have growers, you have engineers, you have different people trying to do different things. You need to coordinate their work so you can simplify that coordination. There's a lot of sensor data that you need to put together in one place. For example, for situational awareness, if you need to make a decision, if your robot is, detecting an obstacle, you may want to do a human validation of that, all the way to ongoing, debugging and improvements on the software. So that's it, and would love to hear questions, and I'll share some links here as well for later.
Thanks a lot, Florian. Yeah, and I see you put the link already in the comments there, so that's great. Cool. Could you give a specific or perhaps a generic, but generic is fine, example of what kind of like intercession might be necessary, especially in an agricultural setting? Like, is there a common time when autonomy might break down, or where it makes sense to have like for some sort of teleoperation, and how is that negotiated in the real world?
Yeah, and of course, like with everything, it depends on the specific case. Doing weeding in an open farm is very different from a fully controlled hydroponic growth environment. So the details might change from one case to another, but a lot of the robots we saw today are autonomous mobile robots, and they can get mislocalized. They can slip, or they can they get like weird reflections. So now if you have a mislocalized robot, you have a couple of options. You can send someone over there to kick it. You can SSH into it and start up RBIS, and it's going to take a while. Or you can connect and in a second say, oh, dummy, your pose is off by 15 degrees, fix it and get it back to autonomy. So we really focus on a lot of these like nudges to the robot. Robots, a lot of them or most of them run on battery. You can run on a battery. They have a server inside, so they run out of memory, like all computers. So actually, any number of things can go wrong, and it's one of those things where the first thing you want is to fix it as quickly as possible. The higher order thing is to learn from all the occurrences of that event, so that it happens less, right? You improve your software on a continuous basis. So this is, one of the things we do is we bring a lot of the best practices for DevOps, where you have these 2 cycles of like short-term mean time to resolution and reduction in the incidence of a problem.
Okay, great, thank you. That also, I think, helps answer another one of the questions from the community there too. Great, so thanks a lot, Florian. I think we'll go to our next panelist to make sure we get time for everybody.